Before we get started, I do want to share this important message from the Dementia Society of America. All content, including any potential medical information, is provided as an informational resource only and is not to be used or relied on for any diagnostic or treatment process. It should not be used as a substitute for professional diagnosis, care, and treatment. Please consult your healthcare provider before making any healthcare decisions or for guidance about a specific medical condition. The opinions expressed and the content shared by me, Dr. Forrest, and her guests are not necessarily the opinions and content of the Dementia Society of America. Thank you. The way we like to start the care conversations is just with introductions so that everyone listening has a general sense of when we say the word dementia, what that means, or our current understanding. At this time, we consider dementia an umbrella term. It is not one disease in and of itself. So that is an important feature that we want our listeners to hear. Within this umbrella term dementia, there are many, many different types of conditions that ultimately present itself under this umbrella known as dementia. And in order to be diagnosed with a dementia, there are varying changes in cognitive functions, at least two or more cognitive functions, where it impacts daily life. The ones you may be more familiar are Alzheimer's disease, vascular dementia, a mix of different conditions, Lewy body, frontal temporal. So the list goes on and on. Many are fatal with no cure. There are some reversible dementias that could happen from things like hypothyroidism, even a severe depression. But the ones that we're focusing on now are the ones that are ultimately progressive and fatal. It can happen in a variety in younger age, but many happen in old age. And you could read more about it from the Dementia Society of America. Today, you are listening to a Dementia Unplugged, particularly Care Conversations, which is monthly, and know that it will be recorded and placed on YouTube, and you can look at this again. We've expanded Dementia Unplugged to also include musical connections and artful insights. So listen for more information, and you could learn how the arts and music play a wonderful role in enhancing quality of life for people with any type of condition that presents as a dementia. It is a great honor to welcome our featured guest today. That's Dr. Michael Fossel. He has his PhD in neurobiology and his MD was at Stanford. He is many published articles in a variety of textbooks. His focus is on cellular aging and human disease. And I'm going to have him speak more about his background in just a little bit, because it's just fascinating. And he's also on the advisory board, as myself, for the Dementia Society of America, and it's just been an absolute joy to get to know him. So I'm going to have Dr. Fossel talk more about himself. And welcome, Michael. Dr. Fossel, thank you so much for taking your time to share your insights into this whole world of dementia. And before we get into the nitty gritty, can you share a little bit about your background and what brought you to be interested in aging and dementia? What intrigued you?
Well, I first started off actually in psychology, graduated back in 1973 and 4 with a master's degree, and then went on to do neurobiology. And they talked me into going to medical school because I was teaching some of the courses. But what I was originally working on was development of the nervous system, which I find absolutely awe-inspiring. It just floors me. And I think it does with most people. But I noticed that whenever I talked about the other end of life and age-related diseases, people invariably shrugged and say, well, what do you expect? Wear and tear, entropy, things fall apart, rust, things happen. And I found that lazy. I suspect almost everything in life that I think looks simple usually turns out to be more complicated once I look into it. And I thought that was true of aging too. There must be more to it than that in age-related diseases. But as I said in that paper I passed you, by the way, it wasn't clear to me where I could start working on this. It was like the elephant and the blind man. You've got 6 blind men feeling an elephant. One thinks it's the ear, one thinks it's the tail, and one thinks it's the wall, and so on. And I found that was true of age-related diseases. Everybody thought it was just mitochondria. It was just something. It was just little things. And none of them seemed to go together. No one had an idea there was a full elephant there. And I suspect that there was. I just couldn't figure out what to do with it until about the mid-90s when I ran into some of the work on cell aging, began to put the bones of the elephant together. And I began to suspect that when you look at age-related diseases, and particularly the dementias, if I look at Lewy body and frontotemporal and Alzheimer's and Parkinson's, they all look to be kind of different. But as I suspected, there's more to them fundamentally at a very bottom level. There's something they share. And if we could truly understand that, then I think we can intervene and prevent and cure age-related dementias. So that's kind of the quick and dirty of it.
Yeah. So this was in the 70s, 80s, and that's interesting. I started teaching a course. It wasn't until the 90s. It was called Healthy Aging at the undergraduate level, and it is amazing how aging it was an afterthought. And here we have the growth in this population, and no one wanted to study it. So did you get any pushback on your interest as a young researcher? And
Yes, yeah. I mean, this is why I get to talk about aging, because now I'm aging. I'm 70. But yes, indeed, people didn't understand it. I'm trying to think of an analogy here, but it's as though we were trying to figure out what caused COVID, and we had never heard of microbes, viruses, none of that, and we were simply looking at the symptoms. And so I've got a runny nose, and I've got a headache, and I've got a cough. And we're trying to treat the cough and the runny nose and the headache and the fever. But those aren't the disease. Those are just the outcomes of the disease. And people aren't looking more carefully and asking what's really causing it. Here's another one that is pretty obvious to me. But, if I wanted to say, how can we predict somebody is going to have dementia? What is the single thing I can know about anybody that gives me the best idea whether they're going to get it or not? Well, it's not your genes. That's not your diet. It's not your exercise. It's your age. Because 25-year-olds generally don't get dementia, and 75-year-olds may. Now, that doesn't predict you will get it, but if I could only know one thing about you, it wouldn't be where you're from in the world or your metabolic rate, or your microbiome. It would be how old are you? And that's true as a single best risk factor, but everybody then ignores it entirely and focuses on the genes and the head trauma and the toxin exposure, and all those are true. But they've ignored this fundamental thing, which is, what does aging have to do with this? Because again, people just throw it off and say, well, yeah, you age, but we don't look at it more carefully. And once you do, but yes, people tended to discount that. I think they discount that sort of the way fish discount water. It's so obvious that they don't pay any attention to it. Mm-hmm. They make what I call the unexamined assumption. They assume they understand it. No, you don't. You need to look more carefully at these things.
And so you started a company. Can you tell us a little bit about your company and the work it's doing?
Well, it started back 2001 because somebody offered me an enormous amount of money to take this to clinical work. And then They got involved in a very messy divorce. They hated each other. They canceled the whole project. And maybe it was just as well because in 2001, I'm not sure we could have done this technically. And then I got involved in another company that was not paying attention to the law, and we got out. But then a friend of mine from the UK came to see me because his mother had dementia. And he had read my textbook and said, let's take this to human trials. So that's where we are now. And we're sort of closing on funding now to take this to a dog study later this year, and then to human trials as soon as we can.
Well, you have a video clip that you want to show the audience. And I think that if you can kind of give us a little background to this video, yeah. And Kevin will get ready to show it in a minute. But if you can give a little background.
Yeah, let me give a little caveat that, the video, it's a video graphics. It's very pretty. And it's done in a UK accent. We get to choose that. But it talks about Alzheimer's, but it's not about Alzheimer's. It's about all the dementias. We just called it Alzheimer's because that's what we're sort of our first target, but it's about all the dementias. And one of the things that got me going in this was that I was invited to lead a conference on animal models of the dementias a couple of years ago in Washington. And the question is, quote, why does everything work in mice and nothing works in humans? And of course, not everything works in mice or rhesus monkeys or anything else, but nothing seems to work in humans. And I said, the reason is because we're not trying to understand the fundamental process again. What is it that is in common between Lewy body and frontal temporal and Parkinson's? What's in common? And why is it that we all know animals? You can't teach an old dog new tricks. My cats, my dogs, you look at horse, cattle, they all have cognitive decline with age, but we don't try to learn from this. So the question is, what's fundamentally shared? This video gets into it, but again, it aims itself at Alzheimer's. It's more than that. Take a peek, see what you think.
It's one of the most common age-related neurologic diseases. It involves degenerative changes and cell death in the cortex of the brain, with gradual loss of cognitive function. Many factors contribute to the disease, but the fundamental process is age-related epigenetic changes in the glial cells of the brain. Neurons depend on the glial cells to function normally. Microglia, one type of glial cell, constantly produce and absorb molecules in a continual recycling process. One common example, beta amyloid proteins, are produced and secreted by the microglia. Some of these proteins are sticky and apt to form clumps. But they are usually reabsorbed back and broken down. This molecular turnover is rapid in young cells, but as the cells age, molecular turnover slows down, leading to a gradual accumulation of the microaggregates around the cells. As molecular turnover slows down even further, the microaggregates grow larger, forming beta amyloid plaques and damaging the neurons. Over the years, these plaques increase, as does the damage to the neurons, which begin to fail and die. Molecular turnover slows down because of subtle but pervasive changes in gene expression in aging cells, which are the result of telomere shortening. Telomeres are the regions at the end of each of our chromosomes that not only protect the genes, but also serve as aging clocks, shortening over time. Over the human lifetime, cells may divide many times, and each time the cell replicates its chromosomes. The replication protein complex attaches to the end of the DNA chain, but can't read the tiny segment of telomere that lies beneath its attached area. So, with each replication cycle, the telomere grows slightly shorter. And as the telomere shortens, it affects the rate and pattern of gene expression throughout the entire chromosome. As our cells divide, telomeres shorten, gene expression changes, protein turnover slows, and cells fail and die. The final result is Alzheimer's disease.
Thank you. I'm glad we were able to share that. And we have a variety of participants on the call, some with a science background, some with not. So I'm going to see if I can distill this. The understanding is sort of the unifying theory is we have these telomeres that shorten, and that starts the cascade onto aging and the dementias. Is that an accurate replay or summary? I'm trying to have a divide here for just to kind of bring it down to a level that if you were to give an elevator speech, Michael, what would you say?
Yeah, I would say that what happens as we get older, never mind the telomeres, but what happens is we're continually recycling things, and it slows down the recycling rate, and so damage accumulates. It's like if I look at the elastin and the collagen in my skin, it's not there my entire life. It's continually being turned over. But the turnover rate at age 7 was a lot faster than my turnover rate at age 70. And so you begin to get wrinkles because things aren't being turned over as fast. So that's kind of what's going on in your brain with a lot of these things, whether you're looking again at Parkinson's or Alzheimer's or frontotemporal. The turnover rate, it's as though I have a friend who's had a car for 47 years. And I asked him, how did he do that? And the answer is he takes good care of it. Well, I don't. My car, lucky it lasts 3 years, but the difference is not the quality of the car, it's the quality of the maintenance. I'm bad at that. He's good at that. But that's the difference between you being young and you being old. It's not the wear and tear. It's the way you repair things and maintain them. Same with houses, same with gardens, same with so many things. The mark of a good garden is not that it doesn't have weeds, it's that it has a good weeder. And that's really what's going on here. The reason you and I get dementias is because we're not cleaning up after ourselves.
So therefore, you're in terms of intervention, so you're working on the understanding, but what do you anticipate being the way to intervene in terms of maintenance? What would that look like?
Well, here's another analogy then. The difference between your cells when they're young and your cells when they're old is the tune they play. If it's a symphony orchestra, the difference between playing Mozart and playing John Cage is not that they have different instruments, or the oboe has got a broken reed, the piano's out of tune. The difference is they're playing a different score, a different tempo. And that's true of your genes when you're young and old. It's not the genes, it's the tune you play on those genes. So what we do is we don't go in and change the genes. We go in and change the conductor and say, different score, different tempo. And that has to do with the telomere. So what we do is we reset the telomere length. It resets as it were, the score, and now it's back to playing Mozart. It increases that rate of recycling. This was first shown 23 years ago, actually, and then shown in human tissues 21 years ago. The question is, can we do that we can do that partway with mice. Can we do that with people? And can we use that to cure Alzheimer's and Parkinson's and so on? And the answer is, I think so.
And how exactly would a telomere be sort of reset? What does that look like? What do you anticipate that, let's say, in humans, or what would that be like?
We use a gene therapy. And to make gene therapy kind of simple, if I take an average virus, it's got an envelope that tells it what cells to attack. And it's got a letter on the inside that says what to do once it gets the cell. And what you do in gene therapy is you take a very special virus that's not known to cause disease in the first place, AAV it's called, and then you remove the letter. You keep the envelope that's addressed to certain cells in your body, and you put your own letter in. Say, never mind what the virus wanted, I want you to make telomerase, for example, or whatever gene is missing in somebody who's got a genetic illness. So what I do is I replace the letter, put the one I want in there, and I mail it in a sense to your brain, and it addresses certain cells in your brain and tells them to make a protein I want, which resets the conductor of the orchestra. Am I getting too unscientific here? I like the analogy. I mean, I could get very scientific and technical, but I didn't think you want that.
No. I mean, this is sort of the explanation. We have our first question. Humans have always aged. Why is dementia becoming more prevalent now compared to 100 years ago? Is there a relation between increased rate of dementia to current human lifestyle, food with preservatives and additives that we eat, tons of medications we take. So, we've always aged. Why does it seem to be more prevalent? And what is it about our lifestyle particularly that may play a role?
Let me put it this way. If I go back to the age of the Antonine emperors in Rome 2,000 years ago, the average lifespan was about 25 years, as best we can tell. In 1800, the average lifespan in many developed countries was exactly the same. That is about a quarter of a century. And almost everybody who died before that died of things like gastritis and dysentery. That is, you died of microbial disease, as well as the problems that Saeed is alluding to here in terms of bad foods, not only with preservatives, but in those cases without them. So you were actually eating spoiled food, which is why people like spices so much in those days. But anyway, bad water supply. Those are the things that kill people. Now, if I go back 100 years, the mean lifespan was about half a century. Now it's about 3/4 of a century. But none of that has affected the aging process at all. We have never made any change in the aging process. So the major reason that we see so much in the way of dementia these days is that people live long enough to get dementia, rather than dying, for example, at age 1. Back in 1990, the leading cause in Egypt was still dysentery. I mean, these things are not that far in the past. And we've gotten a lot better at these things than we used to be. But instead of dying as a child of something awful, now you're dying as an adult of something awful, in this case, Alzheimer's. So that's the major problem. However, that's not the only issue. Example, we know that a lot of the risk factors involved are genetic. We know that there are risk factors with head trauma. So, for example, football players, soccer players, rugby players, these tend to have an increased risk of many dementias, not just Alzheimer's, Parkinson's. Also exposure, for example, to toxins like dioxin, paraquat, are risk factors for Alzheimer's and Parkinson's. So there are a lot of reasons. The major one is that we live long enough to get dementia. If you and I live to age 150, which you can't, we'd all have dementia. But the truth is, usually we have something else kill us earlier. These days, it tends to be heart disease and cancer. But the dementias are out there. They're lurking. They're one of those problems. So to answer that, one, we live long enough to get dementia, and two, the current rates have increased, but not so much because of the things that Saeed is alluding to, with the exception of things like toxins and so on, but mostly because we live long enough to get these things.
We all don't want to age. There's all that whole anti-aging movement, but at the same time, we want to age healthily, right? And with good health. And obviously, you're aware of the people who do live quite well into their early hundreds without any form of dementia. So how do you explain that difference?
It's partly genetic. That is, I think of an analogy. Let's say that there's a large lake, and every morning I go zipping across the lake, and every afternoon I come back across the lake, and I never hit a rock. My boat, maybe it goes down a meter, never hits a rock. And down 2 or 3 meters, there are some rocks, but I don't hit them because the lake is high. Now, assume that those rocks are your genetic risks. For example, ApoE4 alleles, one of the common ones, presenilin genes, or maybe genes for heart disease and other things. They're hiding down there, but you don't hit them because the water level is high enough. Now, as you age, the water level drops. And sooner or later, you will hit one of your risk factors. Now, some of us, if I have, for example, 2 ApoE4 alleles, I have a higher risk of Alzheimer's, but I'm not going to get it at age 25. I'm going to get it, say, at age 55 or 60. But if I have 2 ApoE2 alleles, my rocks are much further down, so I may not hit it at all till age 112. So what's going on is you have all these risk factors, and we all vary. So depending on how big those rocks are, as the water level goes down, sooner or later you hit one. But you also have epigenetic risks, the kind of thing, again, Saeed is talking about. If I have a terrible diet, I've increased my risk. If I'm exposed to pesticides, I increase my risk. So we all live in different parts of the world and in different worlds than your neighbor and your friends and your family members. We're all slightly different. So we have both epigenetic risks that have to do with our behaviors, smoking, for example, and we have genetic risks. Those are the rocks that are hidden down there. So those reasons, we're all a little different. Somebody may never get Alzheimer's or other dementias. Somebody may get them literally at age 25. That happens. Let me give you a sort of an historical analogy before I answer exactly that question, which is in 1903, the Wright brothers got their first plane upwards at 12 seconds, 20 seconds. They proved power flight was possible. But boy, that was not an Airbus 380 and it couldn't go across the Atlantic. Okay, it was early days technically, and yet they did it. That's kind of where we are with regard to gene therapy. We are at the stage of, we can do this, but we can't do that as well as we'd like to. So right now, we can't give this as a pill or an intranasal inhalation, nor quite can we do what we're going to talk about intravenously. We're going to actually have to do it probably in the back, like a lumbar puncture, that kind of thing. But ultimately, yes, ultimately, we ought to be able to do this by a pill. And it will last for perhaps 5 years, 10 years, 15 years, and then you'll need to do it again. So what I'm really saying is it's early days. We can do this, but this is not an Airbus 380 and it's not going at 35,000 feet.
What would you recommend to the audience just in terms of maintenance now? What can we modify? What can we do potentially to keep us above water?
Yeah, again, I'm going to put it in perspective historically. In about 1952, there was a book that came out because it was the middle of the polio epidemic. And the book was called Diet Conquers Polio. Well, diet doesn't conquer polio. Given a choice between diet and the Salk vaccine, which I had in 54, I'd take the Salk vaccine, followed by the Satan vaccine. But if it's in 1952, what are you going to do? I do what I could with the diet. I keep my kids out of the public swimming pools. Same sort of things we do with COVID. So when you're talking about Alzheimer's, we're still in that stage, sort of like 1952, where we don't have a treatment that works, and yet everybody wants to do something. So we do what we can. There's not a lot we can do, and yet you'd be crazy not to try it. So yes, I in a sense, I'd say do everything your grandmother told you and your family doctor told you. Your family doctor cost more, and you didn't probably pay attention to either one of them. But minimize head trauma, minimize exposure to toxins. That includes chemotherapy, which increases your risk, although it beats dying of cancer. There are all these things that that you should lower stress, any number of things. And some of these things probably don't work. Some of them probably work a little bit. Some of them probably work better than others. There's a lot we don't know, and yet none of them will work as well as what we'd like to do. In fact, again, to put that in perspective, there have now been more than 1,100 registered trials for Alzheimer's alone, interventional trials, that have by global consensus failed, and that includes the Biogen study. So, there's reason why many people are pessimistic and don't think we'll ever get there. I think we not only will get there, we will get there remarkably quickly and remarkably effectively.
So, it's fascinating. You hear a lot of work and a lot of money has moved and been poured into the plaques and tangles theory, right? In terms of Alzheimer's related disease. Tell us your thoughts about all the energy being targeted towards that. There is how that relates to what you're doing.
There's a scene in the original Indiana Jones movie where Indiana Jones and Sala are at the dig site, and they suddenly realize, and they say it to each other in harmony, they're digging in the wrong place. We have been digging in the wrong place. And when you're digging in the wrong place, it doesn't matter how much money, how much effort, how big the National Institutes of Health, how many well-trained your researchers are, how hard they work. And Biogen, as of a year and a half ago, had spent in excess of $750 million on this and failed. But again, if you're digging in the wrong place, it doesn't matter how big the excavator is. The question is, where's the right place? You have to target your funding. And that's why we have failed to date. So to sort of respond to the anonymous question that came up about expediting progress, for us to do this through a phase 1 FDA trial just to demonstrate it works, runs something in the order of $11 million. To finish the phase 2 runs something in the order of $35 million, including the 11. But that's remarkably little, not that I have it in my wallet, but it's remarkably little compared to what Biogen or Eli Lilly or the NIH or the EMA or other organizations have spent on this. But it's a matter of targeting correctly. You can dig these things out with a shovel. You don't need an excavator as long as you're digging in the right place.
And so the difference here is the rapid turnover. You're looking at aging as being a bigger part of the explanation.
It really is.
Yeah. Yeah. And go ahead.
Oh, I was just going to say, the same questioner, that the third questioner asked about, government funding and Bill Gates. Throughout history, we have tended to keep digging in the same place that we've dug before. We tend not to sort of go for innovative solutions. To be honest with you, most innovative ideas are wrong. But when you keep looking to the same solutions that you've used in the past, they don't work very well. And the government has a tendency to rely on things like the NIH, which is reasonable. The NIH tends to have people in it who have been doing the same thing for 40 years, perfectly reasonable. But those people are not the innovative people who come up with a new idea. They tend to have their ideas that they've already been using for 40 years. They've mined them out. They're not digging in a new place. This is one of those things we need to dig in a new place. The same thing really been true of Bill Gates. I mean, Bill Gates just put an enormous amount of money, well, enormous relatively, into Alzheimer's diagnosis. Well, in 1950, you could have done the same thing for polio diagnosis. I'm not sure that's the appropriate thing. Likewise, we tend to focus on technical incremental advances rather than understanding fundamental issues. So again, in 1952, if we had focused on perfecting the iron lung, I don't think that was the answer. We didn't need a perfect iron lung, we needed a Salk vaccine. The same thing's true here. What we need is not better and better diagnosis of Parkinson's or Alzheimer's or frontal temporal or Lewy body, which we're doing. But what we need to do is step back to figure out what we're doing. I sometimes say the only way to move forward is to step back and re-examine your assumptions. And that's what we're talking about here.
Well, thank you. I mean, that certainly is a whole different way of thinking about this, really. What dementia is and sort of this unifying underlying mechanism to explain it and to ultimately, cure it.
Again, historically, if you look back, the major thing that we've ever done to improve human lives, medically speaking, is microbial theory. It was not incremental little things that were expensive, like robotic surgery or heart transplants or the latest statin drug, all of which have some marginal improvement in human welfare, but they also are expensive. It's things like washing hands during delivery of babies back in the early 1800s, which drastically cut the neonatal and the maternal death rates. Things like the first polio vaccine in 54, the first rabies vaccine in the late 1800s, the first antibiotics. These are things that actually lowered the cost of medical care and improved the quality of human life. I think what we're about to do is have a second revolution in medicine, which is to understand not microbial theory, but to understand aging and how it works and how it causes diseases like dementias. And again, I think the outcome is not going to be to increase medical care, but to lower medical care costs globally, nationally, and personally. In 1950, there was an estimate that many countries would be medically bankrupt by the year 2000 because of the cost of treating polio victims. And in the year 2000, WHO estimated that the cost of preventing polio was less than 10 cents a head. So much for bankrupting the system. Right now, we're making these predictions that because of the cost of treating dementia, particularly in the last year of life, which can run well over $100,000 without treatment, without curing it, by the way, that we will be medically bankrupt within 50 years. I don't think so. But if that happens, it's not because we're going to have better and better nursing homes. It's because we're going to truly understand how these diseases work and intervene effectively and safely and make people's lives better. Different thing.
Well, thank you for that work on a whole different approach and a whole different way of reframing this. Boy, I can't believe our time is just about running out here. Let's see if there's one last question. No, that was the funding. So I think
it's another one. It says, so do you have enough funding to proceed? We surely hope so. We've been trying for years to convince people. We have talked to several hundred different possible financing groups. without success. We do have one now that's attempting to close with us that is committed to taking us all the way through FDA phase 2 human trials. We'll see. I hope so too.
And I just want to thank you and keep up all of your efforts. This program, as you know, is hosted by the Dementia Society of America. It's a wonderful resource, and there's just a variety of information on how to support caregivers. And as I'm ending this slide, perhaps we can ask one more question that's popping up from the audience, if you don't mind, Michael. It is, so where are you digging? Where and what are you digging for? I think you talked a little bit about this, but just for clarity for this this participant.
Well, what we're digging is at a fundamental mechanism. The one that actually has been shown to have an effect. For example, we can actually reverse the cognitive decline in mice. So we know it's feasible. The question is, can we do that with people? And we'll see. If people want to know more, I gave a link on there to a paper that came out. I've never had a paper, I've had 100 papers come out. I've never had one that got 600 global reprint requests. This one did. The Alzheimer's and Dementia Society invited me to write it. The editor-in-chief actually wanted to join our board. But it explains why we're doing this, where we're going, and how we intend to approach it technically, in a sense. I have to warn you that friends tell me that if you want to read this paper, it takes at least one glass of wine, if not a good single malt whiskey. So good luck.
I love it. Okay. Well, we've been told. Yes, I had the opportunity to read it, and no, I needed not to have wine in order to understand it. Otherwise, it would have been would not have remembered. So thank you for your fascinating work. And again,
the bottom
for those
line,
of you,
I think there's hope, Janine.
So yeah, I think the message is you are bringing hope. For the naysayers who say we'll never find a cure, this is just the way it's going to be. Your message is?
No, it doesn't just happen. We can figure out why it's happened and we can fix it.
All of you in the audience, just so appreciate you joining us monthly. Some of you might just be popping on for the first time. Hope you've enjoyed this. As I've said, this will be recorded and you'll be able to share with others. So Dr. Fossil, thank you again. We look forward to hearing more. And the name of your company is Telesight. Perhaps is there a link or something that you could share with the group so that they could stay informed? And I received a wonderful newsletter, but I don't know if that's something people can sign up for. Telesight.com.
Mm-hmm.
Great.
Anybody who gets in touch with me, I'll be happy to send you copies of the article, our newsletter, my textbook, anything you like.
Oh, well, very much appreciated. Okay. All right. You continue on with your good work, and everyone will hope to see you next month. Take good care.